Now, we're going to look here at how to use Kirchoff's laws. Now, this can be done a couple of different ways. So my advice is learn how to do it one way and stick with it. Otherwise, you can get yourself into a bit of a mess. Now, I'm just looking for a circuit that we can use for this. And here I've got one. What we're going to do is draw a circuit. Now the thing about Kirchhoff circuits, and you'll notice this immediately, is they have more than one source of EMF. That's what makes them a little bit tricky. So we've got two sources of EMF down there. These are resistors. I've got another source of EMF in the middle here. And I've got another resistor here. These are another level up from what you did in level 2 in terms of DC circuits. Now what you've got to do, we can give these resistances if you like. I can call this one 5, I can call this one 7. These are ohms, of course. I could give you the voltages here, 4 volts, 6 volts, 8 volts. What you've got to do in a circuit is decide where are the currents and label them. And so where are the loops? And you're going to have to make up equations. This Kirchhoff problems often become simultaneous equations, so unless they're really easy ones. So if you're going to do Kirchhoff examples, you need to know how to do simultaneous equations. Basically what you're going to do is decide where there are currents, and you're going to make some equations using Kirchhoff loops and Kirchhoff's current laws, which happen at junctions, right? So wherever there's a wire, there's a current, and some places have the same current. So if I decide that there's a current in this wire, I can call it I1. If I decide there's a current in that wire, I can call it I2. If I decide there's a current in that wire, I can call it I3. All right? I haven't said which direction they're going in, but I've said there's currents there, right? Now, I2 is different from I3 because at this junction here, I2 could have a combination of the I1 and I3 flowing through it. So these are all separate. There's no other place in the circuit. I3 is here, 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 and here. I2 is here and here. I1 is here, 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 and here. Remember, what goes into a battery comes out of a battery. So we've definitely labeled all the currents in the circuit. Now, we need to label their directions. So we start by labeling currents. Label their directions. Right? And you say, but I don't know which way they go. Doesn't matter. Any direction. So it's good to go with something that makes a little bit of sense. So I'm going to say that I3 goes this way, which means it goes that way. Right? And I'm going to say I2 goes this way. And I'm going to say that I4 goes this way. Right? Doesn't matter which way you do them. Doesn't matter whether one's wrong. So now we've got them all labeled. Now what we have to do is write Kirchhoff equations. And the way we do this, let's get another bit of paper here, is we choose a loop. Choose loops. And so I've got to decide a loop. I'll bring this back down. For me, I always start on a battery. So I've got this loop on the left. So we could call that going from the 6 all the way back to the 6 this way is loop 1. We could go from the 8 all the way back to the 8 could be loop 2. Or we could go from the 6 all the way through the 8. So there'd be 3 loops here. Current laws, I could do a current law for there. I could do a current law for there. So I can actually write 5 equations, no problem with this. Usually it's best to write 2 equations from loops and 1 from a current junction. And that usually gives you enough information to solve. If you just do loops, you will not be able to solve this. There's a problem with linear independence, which you don't really need to know about, but you need to go with what I say. So with a circuit like this, what you would do is you'd go, okay, I'm going to do the loop on the left. So always start at a battery and end on the battery. I always go from the positive side of the battery, and that means I can write my 6 as a positive. Now you then follow your current. And as it comes to the next battery, if your next battery goes negative to positive and you leave from the positive, then that one also becomes positive. Been around the other way, it would have been a negative. If you go through a resistor in the direction of your determined current, not necessarily the correct direction, then you subtract the voltage. So this would be minus 7 times I1. And now we're back to, so that would be my equation for loop on the left. The loop on the right, from the 8 volts, and I always go from the positive, so the 8, that's 8 positive, then it's negative positive, I come out the positive, so that one's also a positive. I go through 3, and I'm going in the direction of the current, so it's negative. If you go in the direction, if you go through a resistor opposite to the direction you've decided the current is in, it's a plus. Got to remember these rules. So we go through the 3 in that way, so I go 3, that's I3, that's the voltage, and I'm back to my voltage. I've got 2 equations there. It's probably going to be enough if I now use a current equation. So if I now look at a current junction, let's look at this junction. What we're basically saying here is that I3 and I1 equals I2. Right? Because we've got 3, 1, 2 goes out. So what you do is you do your equations and solve them. And if, say, I1 ends up equaling minus 1.4 amps, that minus means you got the direction wrong. So you'd go, okay, I got the direction wrong. So then what you do is you'd go, the I2 doesn't go in this direction. Sorry, I1, sorry. Let's say the I1 doesn't go in this direction. It must go in this direction. And I'd put it down as 1.4. All right. But when you're doing your equations, stick with the direction you found or you used, stick with the numbers you found until you've finished them all. Then you write them in correctly with their correct directions. All right. So don't then change this to a positive, say I got it round the wrong way. All right. So you can do that. All right, that's the basics of how to do it. I'll give you a real example in the next video.